Okay, YouTube, in this video we're just basically going to confront how we can easily identify whether an exponential function exhibits exponential growth or decay, and then just how we can quickly throw together some graphs. And so in the spirit of this word quickly, let's go ahead and review just really quickly. Exponential functions are these functions of the form y equals a times b to the x, or we've been focusing more specifically on letting a equal 1, and we're saying that really we have some positive number to the power of x here, and we're seeing a general curve that's developing. And so one thing that we've mentioned is that as long as b, I'm going to write if here, if b is greater than 1, then really what we're going to be doing is taking a number bigger than 1 times itself over and over and over again. So what we're going to see is that we're going to exhibit a growth function, whereas if b now is a proper fraction, that is, it's still positive but it's between 0 and 1, we're going to see a situation where we're going to exhibit decay over time. And so growth, of course, being something that looks like this guy right here, should get steeper and steeper, whoops. And decay, looking from left to right, is something that is decaying over time. And so looking at these, it becomes pretty simple to identify right off the bat, because we look at the base of our exponent here being 4. 4 is definitely greater than 1. And so we say that this is definitely going to be a growth function, whereas g of x here being 1/5 to the x, we can see that 1/5 times, say, a fifth times a fifth times a fifth, this is going to be something that just keeps getting smaller as x gets bigger and bigger. And so we say that this is a decay function, just because we could say what we know about the base of the exponent. So now in terms of sketching these, it says graph the function. Here's what I want everybody to be accustomed to when it comes to graphing the parent function. The parent function, when I say parent function, I mean this guy right here. Parent. Then we know some basic characteristics of our exponential functions. And that is to say that in terms of what we know about them, we know that there has to be a horizontal asymptote, okay, here on the x-axis for both of these graphs. So I'm going to go ahead and proceed to put that in for both of these here, and we're going to label it in both possible instances y equals 0, because it's not always going to be a 0, but for now, these parent functions, they are. Now, in terms of what I would graph, in terms of tabling two values, I would always say plug in 0 and plug in 1. And again, reason why we plug in 0, we say 4 to the 0 power. If we were to find f of 0 here, we say 4 to the power of 0, we would definitely get 1. So in other words, one characteristic that is very true of all exponential parent functions is that we have it going through 0, 1. And then, of course, 1 comma what? Well, we say 4 to the first power here. If we said f of 1 here, we would get 4. So of course we'd get 4. So we say 1 comma 4. You could see that 0.1 comma b, as we said more generally speaking in the past. And then we'd say that our graph would just be this graph that runs through right here. So in terms of, is this sufficient enough information to graph this? I would say yes. Now in terms of domain would be all real x values, just because we can always raise 4 to the power of something and get a y value back. And likewise on our graph, we can see on the x-axis this is going to cross over all x values. Now in terms of range, the range of values that we saw spit out of this, we see that only y values greater than our asymptote, or all y values greater than a height of 0, exist on this function. So now sketching 1/5 to the x. Now one thing that is clutch we have to recognize is that this is a decay function right here. So in terms of graphing it, I would say let's go ahead and put 0, 1 on here right now. And just because I know I have to be at 1 comma b, okay? Essentially what I'm going to say is if this is 1 right here, then 1/5 we could fit in. If I would have put, this is 1 right here, then 1/5 would be really hard to sketch. So maybe I'll compromise right here. We say this is 1. We'll say this is 1 right here. But basically, it goes through the point 0, 1. And I should table a value. We should table a value on all these. But we always basically plug in 0 and 1. So we say 1/5 to the 0 is 1. And we say 1/5 to the 1 is 1/5. So we would say this would be at a height of about a fifth, which I can imagine being right here. And because it's decay, then it's going to have this basic shape where it's coming down really fast on the left, and maybe slowly, but it's decreasing forever and ever. And we say that this is our exponential growth function right here. Cheers.